This is the first exam review video for the geometry unit for algebra. So use the video as you have for the other ones, where you stop the video and try problems after you get some reminders. We worked on Pythagorean theorem in the geometry unit using our skills with powers and solving. So the reminder for Pythagorean theorem is up there in blue, that it's leg squared plus leg squared equals hypotenuse squared. So as you get into word problems, you want to see if you can make a picture that's going to tell you which pieces of information are the legs and which are the hypotenuse before you start calculating. So they want the length of the diagonal of a rectangle, and this is number 3 in your review, so get that out. So they're talking about a rectangle. Always make a picture so that you can see where the pieces fit. They want to know what the diagonal length is, so I'm going to call that D because they didn't tell me. And the rectangle has a length of 10 and a width of 17. And you can really make either one of these the 10 and either one of these the 17. Doesn't matter whether you drew it longer and shorter or taller and narrower. But I can see from this that the diagonal that I'm looking for is opposite the right angle, so that's my hypotenuse. So our setup then would be 10 squared plus 17 squared equals D squared. Before you go calculating, you want to see if they give us any information about rounding versus giving an exact answer. And in this one they don't, so I think a rounding answer could be okay. So as you go to calculate, as soon as you get it, let's get that answer rounded to the nearest tenth then, we'll say. We'll add some rounding directions. So to the nearest tenth. So pause the video and keep working on that one. If you're ready, then go look at number 5. And again, the other really basic Pythagorean theorem problems you should be stopping at and doing while you're there. But word problems challenge you in both to use the math and to figure out what the picture's got to look like. Mr. DeSalvo decides to go from a run. From his apartment, he runs 5 miles south. So our suggestion was always that you kind of label things. There's his apartment, and from there he runs 5 miles south. So we've always considered that, below things. So 5 miles to the south. And then 7 miles to the east, and east, according to our compass rose, would be that way. And then he stops. So this is where he ends. And from there, instead of running those same 12 miles home, because he ran a total of 12 miles so far, he'd like to go directly back to his apartment. So we'd be looking at taking that path, that direct path back to his apartment. And again, from there, you're going to set up some Pythagorean theorem and solve. In number 6, similar idea, but we want to see if we can figure out where things go. And I've got a picture here, but something you need to understand is that the ladder would be on an angle. So Jessica's cat is stuck up in the tree. She knows that the cat is stuck 15 feet in the air. Well, that's not the ladder. That's actually from where the cat is to the ground. So that's actually this side where we're looking at height of the tree. She puts the base of the ladder, so here's base of the ladder, 3 feet from the base of the tree. Base of the tree, so she's connecting those two at 3 feet. And then she's seeing, now here's the comparison. Those are the things we can't change. That's where she put the ladder, and that's where, that's how high up the cat is. So what they'd like to see is, will the 20-foot ladder reach? So what I'm going to do is not use the ladder as 20 feet. I'm going to solve it with the 3 squared and the 5 squared and see if it can reach. If the ladder needs to be longer than 20 feet, then my ladder can't reach. If the ladder would need to be shorter than 20 feet, then yes, the ladder will reach. So it's a judgment after you calculate. And then you can come back for part 2.